So now we have to find obtuse, and we know in obtuse the dot product has to be negative, and then dot product needs a scalar because it gives us a scalar. So we're going to get the components to the magnitude that we have for any vector, and we get a scalar because we have unit vectors which they're not a scalar, and then we get a scalar value, which is a magnitude. Now with that, we also know they have to use different symbols, and we know that scalar and vector has components, and then scalar does not have a component, it's just a number. And now let's see if using these, how we get. So if we have all these components, we get square root of 61. Again, magnitude of getting the components is we get all the components to the raised to the power 2, we add them up, and then we get the square root of them sum, which we get the square root of 61. For B, we get a square root of 6, same for C. For D, we get square root of 14, and then for E, we get square root of 29, and for F, square root of 10. Now we're going to use all this magnitude that we get from the components and try to add them to dot product and try to use to see if we can again get any obtuse value to get around this values and try to find out what we can get. So I see you guys when I actually do find out an obtuse angle. As you can see here, now we have to do obtuse, and I get magnitudes from components in order to, so we can have now go over and see what we get. So the Cartesian coordinate system, as you can see, x hat, y hat, z hat, it has to be on a 3D, and then I find out, okay, let's see how much from the components we can get. I compared multiple vectors, it didn't work, but when I compared A and E, I get an angle of 126 degrees, that is an obtuse angle, so we can use that in order to prove that we have an obtuse and get our case moving forward. So now we gonna do the dot product. We're gonna get the square root of 61, the magnitude that we get from the components for vector A. We're gonna use square root of 29, which is the magnitude that we get from the components of vector E, times the cosine of those two vectors, which is going to be cosine of 126. When you put them together and get the dot product, you're going to get negative 24.72, which is a negative. So it proves that it's an obtuse dot product. It's supposed to give us negative, so this is correct. A and E are having an obtuse dot product, and we put them together from the Cartesian coordinate system. We give a scalar because we don't have any units, just like how we get from the magnitude and have no units, and we get difference that okay, scalar does not have any unit right now. Or if it has a unit, it's going to have, for example, meter per second. It's not going to have x hat, y hat, z hat, like the vector has. And this is pretty much it. That's how we get the dot product, how that's we get the obtuse, and it's negative. So hopefully you guys learned something new. And if you have any questions, let me know in the comments.